Good morning, students. In today's session, we will be discussing the concept of fog computing. So, in last few sessions, we have discussed several features of cloud computing in general, and from those discussions, one thing which definitely came out is that cloud computing is a continuation of the earlier technologies which were based on distributed computing paradigm in general. So with that relation in practice, so with that evolving relation, ultimately cloud computing brought about a totally new technology in place, and that is the concept of fog computing. And in today's session, we will see the general concepts of fog computing in brief. So basically, what do we mean by fog computing? That we have to know first of all. Uh, right now, Internet of Things or computer IoT computing technology has become much popular since a few days. And to implement the various IoT applications, fog computing or edge computing does play a very vital role. That's why fog computing is also gaining much popularity nowadays. So, at a very basic level, what do we mean by fog computing, and what is the future of cloud and fog, that we will review in these slides hereafter. So, from the earlier discussions that we have on cloud computing, uh, we have seen some limitations of cloud. What were those limitations? Those limitations were connectivity is an issue in cloud computing. That means if the connectivity is poor, then we cannot access the various cloud services in a seamless manner. Connectivity to the cloud is a prerequisite for efficient cloud computing services to take place. And some IoT systems need to work even if connection is temporarily unavailable. That means in the IoT domain, cloud computing does bring about certain difficulties. And another point is not always enough bandwidth. Cloud computing assumes that there is enough bandwidth to collect the data, and that thing is not always found in practice. Third is cloud computing centralizes analytics. Now see, though cloud computing is a type of distributed architecture, but still cloud computing also consists of some uh, data centers which are located at some few places throughout the world. And in those data centers, we are collecting several computing resources that will be used for the processing purposes. So it is ultimately following some sort of centralized way of computing, we can say. And fourth is the security shortcomings. Now, this is common to all the distributed computing architectures, whether it's a cluster computing or whether it is grid computing or cloud or fog, whatever. Security issues are there, and for that reason, security challenges is always an ongoing process to secure the infrastructure in a more better manner. Now, if we rely only on cloud-based computing, then what will be the issues? Communication taking place a long time due to human smartphone interaction, that is one of the issues. Data centers are centralized, and so all of the data from different regions can cause some sort of congestion in the core network. Now see, as the data centers are situated at a very few places, so what will happen? uh, Data from all the customers or the end users, they will be trying to reach the final destination at a particular place only, and in that way it will again cause some sort of logjam in the network. And such a task requires very low response time to prevent further crashes or traffic jam. That means if the response time is low, then only the infrastructure can service at an expected level. So these are the issues with cloud-only computing type of architecture. Now, to address the limitations of cloud computing, fog computing basically came into the market. And it was the networking major Cisco Systems which introduced the concept of fog computing in the market in around year 2014. So the term the fog computing was introduced by Cisco Systems as a new model to ease the wireless data transfer to distributed devices in the Internet of Things networking paradigm. So basically, as I told you, fog computing is mainly used in the domain of IoT. Fog computing is also known as edge computing, and it's a particular model in which data processing and applications are concentrated in some devices which are situated at the network edge rather than almost entirely in the cloud. So basically, what is happening here? Fog computing is making the task of cloud computing somewhat easier by offloading a major part into its own devices. So basically, fog computing devices sits in between the customers or the end users and the cloud infrastructure. So if we consider the end devices, then the fog computing devices are situated very near to the end user devices or the customer side. So what basically happening is that the data that we generally store in the cloud servers are being maintained, are being processed, and are being stored at some specific devices, and those devices are situated at the very edge of the local networks. So that is the usefulness, or that is the working principle of fog computing in general. Now, the Cisco's vision of fog computing is to enable the applications on billions of connected devices to run directly on the network edges. Users can develop or manage or run their software applications on Cisco framework of network devices, including hardened routers and switches. Now, see, basically, Cisco is the market leader in manufacturing various types of specific network equipments like routers and switches, gateway devices, access points, and all those things. So basically, they have modified their existing network instruments to make them more sophisticated, so that they can leverage the technologies of fog computing in a more efficient manner. And in this respect, trying to make a Cisco is trying to make the usage of some open source protocols, open source operating systems like Linux operating systems and network operating systems together in the single network device. As there will be manufacturers, as there will be equipments of different manufacturers to establish some sort of interoperability among themselves, Cisco is favoring open source software usage in this respect, and they're also going to the domain of software defined networking, where instead of putting much effort on configuring the devices through commands, the end user should be able to configure the devices using some centralized software control mechanism. So that is the concept of software defined networking, and Cisco is also ultimately going to realize that principle in the future, in the coming days. And as a result of that, we can say that Cisco is the flag bearer in manufacturing devices which are being generally used as a part of fog computing. But nowadays, other major players such as IBM or Amazon, Microsoft, they are also coming into the market to produce their own equipments which are also used in the fog computing architectures. So here in this particular slide, you can see a graphical representation. So what it is saying here, whereas the cloud is up there in the sky somewhere, distant and deliberately abstracted, the fog is close to the ground, right where applications are getting done. So basically, what you can see here, that is the edge devices, which consists of several sensors, smartphones, laptops, which smart access points, which are generally supporting the mobility concept, and these edge devices are being connected through the fog nodes, and ultimately at the very top we have the cloud data centers where the data is being stored for some sort of long time analysis. So whenever we are dealing with the data for some specific applications, say for example machine learning or artificial intelligence, we need to analyze those data um, with the so we need to analyze those data, and those calculations are being carried for a long time, and those are generally stored in the cloud servers. But when we are dealing with real-time applications data, at that point of time, the fog nodes are enough to compute all sort of processing applications, and thereby the fog computing is becoming very popular to realize the to realize the IoT architectures. So what are the features of fog computing? Fog computing is bringing the intelligence down from the cloud close to the ground or where the end users are situated. Cellular base stations, network routers, Wi-Fi gateways will be capable of running various sort of applications here. So the various telecommunication systems of which cellular base stations are a part, or network routers, Wi-Fi gateways, they all are bringing to, they all are being brought together to realize this fog computing paradigm. And the end devices like the sensors are able to perform some basic level data processing, and processing close to the devices lowers the response time and enabling real-time applications. So as I told you, say for example, somebody tries to implement the concept of smart traffic system or smart cities, where there will be several applications which need to be done at the very real time, and these real time applications are generally used or generally implemented using the IoT computing paradigm, and in such cases the fog computing plays a vital role. So here, so here in the diagram, you can see that at the very bottom level, we have several end devices like cars, laptops, servers, smartphones, and they are being connected to the fog nodes, which are some specialized devices, and those devices are again connected to the backend cloud. So at the top, we have the core architecture, and at the edge, we have the fog devices. So this is how the particular system has been built with. So fog computing enables some of the transactions and the resources at the edge of the cloud, rather than establishing channels for cloud storage and utilization. That means we are offloading the jobs of the cloud systems into the fog systems. Fog computing also reduces the need for bandwidth by not sending every bit of the information over the cloud channels, and instead of aggregating at some fixed certain access points. As each and every bit of data need not to be sent in the cloud, that means we are saving the bandwidth here, and also our response time is much low, because those processing devices are being situated very close to the end users devices. So this kind of distributed strategy will definitely help in lowering the cost and improve the efficiency of the system. This is one more diagram which is being shown to you. Sensors which perform some sort of data pre-processing and compression. Mobile devices such as smartphones, they are being used as the edge device of the end users devices, and they are being connected to some PCs, notebooks, home gateway systems, which are acting as the fog sites for some sort of real-time data processing, data caching, computation offloading. Why computation offloading? Because otherwise we should have gone for the cloud servers, and if we have gone for the cloud servers, then definitely it would have increased the response time from the servers, and ultimately the real-time applications would not have been possible to implement. So that's how fog computing plays a very crucial role in such a scenario. Now the fog computing enablers. So what are the particular entities which helped in the realization of this fog computing architecture? Virtualization. As you have seen in the cloud, in case of fog also, we can implement virtualization effectively. Virtual machines can be used in the edge devices. And next is containers. So what is basically containers? Containers are some lightweight virtualizations, and it reduces the overhead of resource management. Example are Dockers. Next is service-oriented architecture. So as because fog computing is also very much web-based, so it is also following the service-oriented architecture computing paradigm, which is a style of software design where services are provided to the other components by application components to a communication protocol over a network. And lastly, we have the software-defined networking. As I told you earlier, software-defined networking is an approach to using open protocols such as OpenFlow to apply globally, aware software control at the edges of the network to access the network switches and the routers that typically would use cloud and proprietary firmware. So ultimately, we are going towards the notion of software-defined computing or software-defined networking, basically, where we would be using different types of open protocols to communicate, and these devices should be aware of each other and they should be controlled from a central point. uh, that will make the task of the administrators much easier instead of manually configuring all those devices individually. That is a huge task. So these are the particular entities we can say that enables the fog computing to for realization purposes. So what are the specific benefits of fog computing? One is low latency and location awareness. In case of cloud computing, the end users, they are not very much aware of the existence of the data in the cloud. But in case of fog computing, the devices are aware of the existence of the other locations, of the other devices, basically. And it can be used, it can be implemented with a widespread geographical distribution. It supports mobility. There are various, very large number of nodes. So compared to cloud computing, fog computing employs very large number of nodes. And it is highly based on the predominant usage of the wireless access systems, and various sort of real-time applications can be done by it, and it supports heterogeneity. So that is a common feature of every type of distributed computing architecture. So these are the specific benefits of fog computing. So now we will go for a detailed comparison between fog and cloud. At the very top, we have the point latency. So cloud computing's latency is high compared to fog computing because the access time to cloud is much larger compared to fog computing devices. Delay jitter, it is also high for cloud computing, but very low in case of fog computing. Location of the server nodes. Now the server nodes can be located throughout the world in case of cloud computing, and they should be connected to the internet only. So we can say that within the internet, the servers are located. But in case of fog computing, the processing devices are situated at the edge of the local networks. And the distance between the client and server, in case of cloud computing, it can be multiple hops. In case of fog computing, it's only one hop. That means they are situated very nearby. Security. In case of cloud computing, the security is not totally visible to the end users or the customers at various places. See, for example, in case of private cloud, the end users, they have to be satisfied with whatever they are getting. They don't have enough say on the various security features provided in the cloud systems. But in case of fog computing, it can be defined in a more efficient manner. And next point is attack on data and router. It has high probability for cloud computing because the path that needs to be traversed is much larger compared to fog computing. Fog computing, attack on fog computing is very much less probable. Next is number of server nodes. Compared to fog computing, cloud computing supports few number of server nodes. And in case of real-time interactions, both support real-time interactions, but though cloud computing will be taking somewhat more time to process. And lastly, location awareness. So cloud computing, like, it's no for this particular feature. In case of fog computing, it is yes. So this is the differences which are generally found in cloud computing and fog computing. So with that, we will be ending our today's discussion here. So if I just make a summary, fog computing, we can say it's an extension of all the previous distributed computing architectures, whereby much importance is being given to the implementation of the fog architecture in the domain of IoT. And as because in the future or coming days, IoT will be playing a much important role in the society. For that reason, fog computing is also gaining much popularity since last few years. So it is highly dependent on the cloud, and at the same time it does offer some solutions which we generally face in the cloud. So keeping that in mind, fog computing will be the next revolution in the coming years to follow. So with that, we will be ending today's discussion here. So thank you.